Alright, we're all here today, but for what it's worth, here's the book. Alright, so we end up with a 6. Now is blue the same as red?
Not the odds, but like the beginning probability is the same.
Yeah, so blue is a half, but then what's its split?
1/2, 2/5,
Cow, pigs, and chickens, right? So cow, pigs, chicken. Alright, so what's cows?
I haven't really said
They say if the spinner lands on blue, player reads in blue box.
So there's a 1/10 chance of getting a cow,
Alright.
a 2/5 chance of getting a pig, and a 1/2 chance.
Like 1/10 here on this branch.
Yeah.
So this is then 1/20th. Sorry, what about pig?
So pig, yeah.
1/5 on the branch, so it ends up 1.
No, it's 2/5.
2/5 on the branch and 1/5 on the bottom.
And what's on the branch for chickens?
50/50, so like 1/2.
1/2 of the 1/5.
So then this ends up being 1. On the branches, we put the probability of the event.
Normal inanimate sports that do nothing except sports.
Some people like to use the branch as like the division bar. Alright, so do a quick area model to represent the sizing of all of this. Joe, get to business.
It just sounds.
You just add the probabilities of both.
Area there. Is that what you sort of do an area model?
Yep.
So.
Oh, okay.
That was funny. Just kidding. Oh. I'm sorry, I'm very annoyed. Because I'm really stressed out because I won't have Spanish on Monday, but I won't be able to come to extensions because I have club. You know, when I was orthodontist on Tuesday, I don't want to be late. I'm worried because I think we can't even go tomorrow for AO because tomorrow we have to do a presentation for Billboard.
Are you going to AO?
Your class is taking it like honor and steroids.
Oh my god, it's not. It's IG.
Yeah.
It's not. It's all
They can't offer it actually.
Is there anything else?
Not though.
Yeah. We have to get
No, it's a completely different
Math
program.
or anything like
No,
that?
it's like international.
Trying sort of practice?
Glory, I know what it is.
All I'm saying is you're standing here doing nothing.
I did
it. About it.
I wish I could go to the meeting, but I can't because I'm only gone.
Are you gonna be at
You're
the
gonna do the college credit plus thing.
No, because that only applies to in-state.
I can't. Wait, are all AP classes college credit plus?
No.
No.
College
So
credit
AP
plus is a
Psych
separate
is not.
software. AP Psych is a different thing. You have to take so AP you take like a test at the end and then they basically say like if you score high enough it means you get
It's
credit.
like a 1, 2, 3, or 4.
I heard political radicalism. is really
Yeah,
popular.
it's Polyred. My sister's taking it this year. She says it's really fun and really
So,
I don't want to.
this should be the area model that we're looking at. Now, it kind of makes me laugh because I just think of it as like a farmyard. So, what's the least probable outcome here?
Cow.
Hmm?
Cow.
Ooh, blue cow, right? Thank you for raising your hand. Sorry that everyone just
Blue
didn't.
cow.
Getting a cow after having gotten a blue,
Yeah.
right? So getting a blue cow. That would, is that when they make blue cheese?
I wish.
Oh,
No, it's chocolate milk.
Chocolate. That's brown cows.
They ought to be a chocolate now.
Brown cows make chocolate milk. All right, so let's get to the part of what we're at. Conditional probability. What is the conditional probability that you got a cow from having a red spin.
1/3.
So we're assuming you got a cow. What's the conditional probability that it was from a red spin? Take a minute to actually think about this, but just about answers. Think back to yesterday, how we calculate this.
Wait, so given the cow.
I think I got
Ethan,
10/13.
how? I'm not going to tell you yes or no yet.
Okay, so yeah. So I guess I looked at the different ways you can get a cow, which is from red or blue. So there's 1/3 and 1/10. So I just
Sorry.
I made those like out of 30 instead to have a common denominator.
Ooh, so you looked at, so because it switched colors back on its own. The probability, every time I pick up the eraser, it's switching back because how it's. There, now we can all be happy. Probability of red, given that we chose a cow. So really, if we don't do common denominators or anything to begin with, what goes on top, what goes on bottom? You can just tell me, like not even the fractions, but what and what.
Red goes on top.
We just mean half and
Oh wait,
half.
no, red goes on the top and the total probability of the cow.
So red cow goes on top. Total cow probability goes on bottom. Yes. Red cow, total cow. We're getting there. You said it, still have to explain it. I thought you said we still have to explain it. So red cow, in the situation that we had, what was red cow's probability when we got down to the bottom? 1/6. Blue cow's probability was 1. Ooh, see, that's the thing. You said make common denominators of 30, but if we're talking about this region, that's not a probability of a third. That's actually the probability of a 6th. This is 1/20. So the whole region together I have to add a 6th and a 20th. So we make it out of 60. We can actually make it out 60.
So that would be 60 out of.
So 10 60ths and 3 60ths. Right? Multiply by 10, multiply by 10.
How'd you get the 1/6? So we do the probability of the red cow.
The red cow's region. It was so if we're talking area model, especially if you envision this, it was 1/6 of the area if the area is 1.
Okay.
The blue cow was 1/20th, so to find our total cow, 1/6 plus 1/20th. Division by a fraction, what do we actually do? Multiply reciprocal. So 1/6 times. You should quickly see, because you're Math 2 students, that we can cross reduce. Yes. Cross reduce. This becomes a 10, that becomes a 1.
10/3 or 3 1/3.
10/13. Be careful.
I am smart.
Does that answer make sense to us? Because if we're getting a cow, what's more likely that we got there by red or got there by blue? Got there by red. So then we can figure out the probability of getting blue, assuming we had a cow.
I have a joke.
No.
No, okay, it's related to this sort of. Okay, so teacher asked the kids, what do chickens give us? The kids say, eggs.
Why?
What do pigs give us? Bacon. What does the old cow give us? Homework.
I don't know that joke. I don't really
Oh.
Okay, so approximately, this would be like 77%.
So relatable.
Now look at F. What is the conditional probability that if we had a pig counter, our spin was a blue?
So same process, right?
Same process.
Blue pig.
Oh, so can red and cow exist together? Are they independent? Or sorry, that was mutually exclusive. Are red and cow independent? What does that mean? What is independent?
Well,
Not influenced by each other.
choosing red is not influenced, but choosing cow is influenced because if you do blue, there's a 1/10 chance getting cow. If you choose red,
Yeah,
there's a 1/3 chance.
So is it independent?
No, it is
No, it is
I
dependent.
know you can get rid of
Because
them,
it's
but
dependent.
they're not independent.
So, are we having the independent argument back there too?
Yeah.
So, independent would mean getting one result does not impact the other result. Does red or blue impact getting cow? Yes. Since the probability of cow in red is different than the probability of cow in blue, 1/3 versus 1/10, the red or blue impacts cow, therefore they are not independent. So they're dependent. Does that make sense? It affects it. If this was 1/3 of red and cow was 1/3 of blue, if their probabilities were the same, then it wouldn't matter whether we got red or blue. We'd just have 1/3 chance of cow. Yes. It's a funny situation. You never played this game before? I'm joking.
Let's play it in class today. Let's play Build a Farm right now.
Go buy it. Go
Oh,
buy
you're
it.
not completely ridiculous. That makes no sense.
You shouldn't get a ridiculous height. What do
We're
you
on
have?
12-8.
Yeah, that doesn't make sense.
Uh-oh.
Like,
Wait.
All right. Conditional probability of blue given
I got 311.
pig, right? Blue given pig.
Blue, green, pink. Okay.
What is our probability of blue pig?
It's,
That's 2
Yeah.
tenths.
That's gonna be
2/10, right? 2/5 times a half. 2/10. What's our probability of red pig?
oh, okay, that makes sense.
So what goes on the numerator?
3 tenths.
Sorry, that's 2.
Oh, 2 tenths.
Yeah, sorry. So really, it's 1/5, right? We can reduce it. Let's make our life. If we can reduce, that's going to make it easier in the long run. So reduce it if possible. Blue pig's probability is 1/5. Total pig probability, kind of annoying, right? 1/5 plus 1/6. 11/30. What can we do here?
Reduce, reuse, recycle.
Yeah, we'll cross reduce.
well,
6/11, not 7/11, 6/11. I've never asked anybody. Terrible.
Why is this close to half?
Because they're very
that is
close.
because, yeah, Chris is about to say, I'm going to say first, the probability of getting a
red
pig,
pig.
getting a pig, given that it's blue, is very similar to the chance
Is it red?
that if we get to stop it,
You guys are
that
being
you get a
jerks.
pig, given that it's red. The chances are, it's 1/5 and 1/6.
Yeah.
Very close.
1/5 and a 6 are very close. Their regions are very similarly sized, as opposed to not very similarly sized. One of these days, Ethan's gonna haul off and just like smack you, and I'm gonna have my back facing the class.
Oh, that'd be great.
Okay.
That's a joke. I don't promote violence, but you guys gotta calm down. You guys gotta chill. No,
Why do you teach math? Is it ready?
I'm confused by that question, Siri. All right, let's look at 80.
Frustrating.
So we have a carnival canteen this weekend, right? Or
Oh,
tomorrow.
yeah.
So,
Oh,
yeah.
I like canteens. They hold
Are you
water.
going?
Yes.
So-
You know this.
Actually,
Do you have a question or answer?
No, I'm trying to high five him, but he won't.
I honestly feel like a week ago I was trying to
High
smoke
five
you.
him.
Yeah,
You're
the
normally
weirdest
by
freak
his side, where you can. And probably roll you could probably. Why? Probably.
Because
That's you're also that time of
All right, can we like refocus? You guys are making this drag out really long, and we could be getting through it more quickly. All right. So one game is flip to spin or roll. So first you flip a coin, then that's going to determine whether you spin a spinner or roll a die. If you end up on heads, you spin the big wheel and it has 10 sections. 3 red, 3 blue, 4 yellow. If it comes up tails, you roll the die. It has 3 red, 2 yellow, and 1 blue side. If the player ends up with blue, that player wins a stuffed animal.
We're assuming the dice isn't weighted, right?
Correct. Fair die. Well, I mean, it has weight. It can't not have weight.
Oh, I mean. Oh my gosh.
Try this on your own. If you actually stay on task, I have good confidence that you can do this.
What? I think this is mandatory to tree diagram. I think this one you have to do a tree diagram for, unless you do like 3-dimensional.
You don't have to draw a tree diagram.
I'm doing a
It's just saying draw a diagram.
If you draw an area model, would it have to be 3-dimensional?
No.
no.
Yes.
You could have done it like the last problem's area model.
Oh.
Red, yellow, blue.
I don't know.
I just wrote that down.
The only difference is that the top section and the bottom section aren't going to be the same, like, actions.
I'm doing that.
Okay, so this is interesting. You're fine. This is the interesting thing that 10 outcomes, 6 outcomes. The fact is that should be showing 100% and that should be showing 100%. So even though they have different amounts of outcomes, really we should make it rectangle. Does that make sense?
I just want to hear about time.
Because the graph paper, I get it. I get why you did it. But in the sense of what we're actually doing, if we're using the area model, it's basing the rectangle off the actions that are happening with the choices.
Oh, now it's that
Do you want us to do
that
B
you
too?
get blue for the head.
Yeah, yeah, yeah.
So wouldn't that be?
Tyler winning the stuffed animal, he takes home to his girlfriend.
No.
Wait.
He just a cowboy.
Well, if he's at the carnival playing games alone, maybe not.
Probably. He sounds like a friendly. Probably so long.
Sounds like a lonely person.
Like one, and it sounds like
Bigger the prize, the lower the probability in the game is. There's a really good YouTube video presentation on that.
Yeah.
So, red, blue, yellow, we're breaking up the 10 sections, and we had 3, 3, and 4, right? So I tried to make my 4 section a little bit bigger. The number cube broke up red, yellow, and blue in 3, 2, 1, right? Or it's, yeah, 3, 2, 1. Yeah, my regions came out a little bit awkwardly sized. I should move the one. Probably more like that. Now, Ethan and I just had an interesting conversation because he's using graph paper. He actually made his area model look like this. Because 10 outcomes, 6 outcomes, something similar to that. Now, while I totally understand why he did that, if we're using the area model, we're talking about a rectangle. So although this had 10 regions and this had 6 regions, both are showing 100% of the heads outcomes, 100% of the tails outcomes. Area model has to use that rectangle. So then, if we're just trying to fill in what we know, what are all these probabilities? What's my probability here? Thank you. 3/20ths, right? Watch that denominator.
I know, I just forgot to multiply them.
Same thing here, and 2/10ths, right? Sorry, I was reducing, but I got ahead of myself. 4/20ths, 2/10ths.
It's just 9. Which is 1/5.
Tails, red.
Wait, why did you simplify that to 1/5?
Oh, yeah, sorry. No, half and fourth.
Okay. I know this. Oh,
1/5.
I know. Oh.
Guys, chill. I don't want to have to move you. So Ryan, this is one of those like prove me you know what's going on, and then I can like leave you alone a little bit. If he gets a stuffed animal, how do we determine what the probability was that he started off flipping heads?
Okay, so first define the probability that you got the stuffed animal.
What do you mean the probability he got a stuffed animal?
Like the,
What are we looking for on the table for that? What gets a stuffed animal?
blue.
Blue, right? So we're looking this region and this region. So
And then you do the common denominator of 60.
common denominator of 60 makes 9 60ths and 5 60ths, making 14 60ths, 7 30ths. It's an interesting fraction. Okay, what do I do then, Ryan?
And then you take the fraction of the one that you want to get, which is the blue from the heads, so 3/20ths, and put it over that.
Wow.
And then multiply it by the reciprocal of the
So
Simplify.
You should have left it as 60.
No, wait, just simplify it. 9/14.
I get to the same place almost just as quickly.
But it's
So we can.
easier to-
I know. I've been like asking it, and that's why I tried to skip it on that one. So thank you. But so we can cross reduce here, right? But since it's a 10, if you wait, you can just chop off zeros. So either way, whether you cross reduce with the 10 or chop it off here, when you're reducing by 10, I find it just as easy to wait. And not right or wrong. I'm just saying, just showing you the difference. It's like 6 in one hand, half a dozen in the other. Does it make sense that we are at 9/14ths, which is over a half?
Yes.
Why?
Because, I don't know where it goes. Logic reasons.
You?
Okay, so the probability that you'll just get heads and then blue is
Oh, wait.
higher
Yeah.
than the chance that you'll get tails and then blue.
Look at the size then.
Yeah.
We're comparing what's the chance of landing here compared to landing here if I have to land in one of them. Well, yeah, this is a better chance than that. Think about dartboards. Okay, I'm going to keep cycling back to the whole, if we're using area model, think about a dartboard. If you have to hit blue, which section's easier? This one. Which, of course, then its probability comes out better than half. Make sense? Okay, we got like 13 minutes left. Let's go help Raul. He's doing a survey. So we're going to get more into stats as the year goes. So they start to introduce a little bit more statistics. So Raul surveys 200 people. 200 people. Go ahead and check out the results. Build yourself a data table. Sorry, my knees hurt. I worked last night and I did not sit down until about 10 p.m.
That sounds fun.
That's okay. For those of you who are sympathetic, empathetic, or whatever, and maybe have noticed that Mr. Estes is not here, it is official. He has influenza B. So he has the flu.
Kate just got over it though.
If you feel like it, shoot him a text or email or something. Tell him you feel better. Apparently, there's a Tamiflu shortage. The stuff that you take when you.
I'm worried Tamiflu season. I always get the flu like every other year, and it's really weird.
I had like sort of like.
See, and now I want to be a jerk and text back. Had you gotten your flu shot? I'm not going to.
I know, I should have gotten.
But I'm pretty sure Mr. Estes is like anti-flu shot.
I already got it. I just got the.
So an interesting article I was reading the other day, while you do some of this math, is about healthy clusters. So if you're talking about surveying and statistics and these sort of things, and you think about it in the health sense, there are these things called healthy clusters, which is high density areas of young people or healthy people compared to old and unhealthy and whatever else. Where are we going? Yeah.
We need like one more piece of it helped.
Okay, so if I'm just going to fill in the table that they've given me here, I'm going to get the smallest pen that I can. All right, so 200 would go out here, right? That's our total of the totals. 78 students have access to a car on weekends. So I think that goes here, right? Which means what goes here? The complement, right? All because it doesn't tell you doesn't mean that we don't know. 54 students have regular chores assigned at home. 80 students have neither car or chores. Where's that go?
That goes in the bottom right.
Bottom right. So this is 80, no car, no chores, which means no chores, yay, no car. Get a bike. What else? So where's the 70? So I put the 70. Where's the 54 go?
Top right. Top right.
Right, like out here?
Yeah.
And you subtract and you get 146.
Can I figure out this?
Yes.
What is it?
42, and then you figure out the other
Can I
one.
figure out this?
12.
Now wait, Chris, you said I needed more information.
Yeah.
Can I figure out this?
I realized it.
You get 66.
Thanks to Ryan.
Yay, I did it.
Look at how nice that is.
Yeah.
Guys, we only had a couple pieces of information. So, especially when you enter into those testing situations, do not restrict yourself with only what you're given. Set up a model so you can make sense of it, find out the unknowns. So, do you see an association between car privileges and chores? Explain why. So take a moment to analyze. Do you see an association between having a car and having chores?
Or we can just sit here and on.
Think about the fact that we're doing conditional probabilities. Well, you're going to have to be able to present to me the probability, so it'll be a whole lot faster. Colin?
I did find a correlation between car privileges and chores.
How so?
Rather, a lack of chores and car privileges.
Okay.
You see, 66 and 78 people with who have a car do not have chores.
So wait, you said 66 out of 78?
Yes.
So you're saying the probability of what? No chores, assuming car?
Yes.
So, how can we say no chores quickly?
NC
Well, that's also no car.
NCH.
No, see,
NCH. Pinch.
Okay.
Without-
NCH. Okay, so
Pinch without the I.
NCH. No chores given car.
Pinch. The parentheses.
And that is. Chill, guys. What'd you say?
66 and 78.
So that's pretty high. That's a pretty strong probability. What'd you compare that to?
well, wait, what?
What did you compare that to? We have to compare, right? To say that there's an association. Like,
Compare.
otherwise, what's your statement? Like, what are you saying?
We compare it to the number of people who have chores but also have a car.
I got
So
something.
it'd be
If we
213
look at the
versus
complements, I mean, just to get things down here, the probability of having chores, given that you have a car, is only 12/78. That's pretty low. Like,
213 and 113.
Yeah.
Statement. I'm not sure that that's exactly accurate because you're not looking at the probability. I think shouldn't you be looking at the probability of like having a car given that you do chores? Or
ooh. So you're saying set it up probability of car given chores.
and then also compared to probability of car given no chores.
Okay, so what's probability of car given chores?
Car given chores 12 over 54.
Whoa, but that's the most practical.
Interesting. 12/78 is 12/54. So I'm curious if those relate with each other. I mean, 12 obviously comes from the same place. Sorry, you gave me another. I'm running out of board. You gave me another probability that we need to look at. Was that
Car given no chores.
car given no chores? So you're just flipping these around.
Yeah. Which would be 66 over 146.
Car. Yeah, 66, 146. Do we all see how we're pulling these values out? Okay. Sometimes you gotta look at a lot of things before you can really make statements. What's the probability of just having a car? Just in general?
39%.
Yeah, well, so 78 out of 200, about 39%. So we just want to compare some things. The general probability of having a car is 39%. What was the probability of having a car if you had chores?
Car if you have chores.
Well,
That's like
2
22%.
What is it?
It's like 22%.
Or 2 nines.
Well, we're looking at percent.
Well, but 2 nines would become 22%, so you're fine.
2 nines
You're,
is more exact.
hey, you're not arguing, you're agreeing.
2 nines is more exact.
Does that help us at all?
Should we look
Well,
at
you
car
can look
given
at
no
the-
chores?
What's the probability that a kid has chores?
27%.
Yeah, that's
54 minus
Calculator.
think about it.
27%.
Think about it.
Actually,
Is it 20?
27%.
Yeah, 27%.
He's good.
So now we know just the probability of a car out of everybody, just the probability of chores out of everybody. But, I mean, which probability of a car given no chores?
That's like 45 or 46. I don't know.
You're
around
fucking
45.
Yeah, I know. That's not, I remember that.
66,
Yeah, it's 45%. Yeah. I am fully
Minus
exact.
4 exact.
Take it. What do you think?
What we do is
Does having a car affect the probability of having chores?
Yes.
I would
Lower.
say
Yes, lower.
solid.
What is this? You're funny, Ryan.
15%.
Join in math class.
Oh, I didn't see the equals.
We might as well just do this while we're at it. Well, that's going to be the complement, right? So that's just 85%.
Okay.
Oh, I mean, it has to be the complement. So I was going to.
So if you have a car, it's much less likely that you have chores.
So are they independent?
No.
And if they're not independent, what does that mean?
Does they affect each other?
There's an association. Right? Because the probabilities are different, right? They are not independent, which sounds redundant in a way, but they relate to each other. They affect each other, right? Because my probability of having a car changes when I assume chores are not chores. My probability of having chores changes if I assume car or not car. Well, we never did not cars. Well, my probability of chores changes if I have a car. If I have a car, my probability of chores goes down. What the heck? What then could you maybe say about those students / parents?
So rich.
They are wealthy.
Yeah, maybe they have a car because they also have a house cleaner, right? Like maybe they have a car because they also have all these freedoms that their friends don't. Maybe they have a car because they're older, and older students don't have as many chores because they might have a job. So we flip it, instead of maybe they're rich, maybe they have a car because they have a job, and therefore they don't have chores.
Maybe they want to raise the son where grandpa dies and they're like, money.
Are you referencing a book?
We're gonna buy a liquor store. No,
Wait, they
don't
buy a
do
liquor
it.
store?
Yeah, that's
the
what
reason
he's
they're
talking
using
about.
the
It's all
Interesting.
about-
My buddies just bought an old grocery store. Like it's closed down. It was like we used to go. It was like a convenience store in a way.
And then I did them all.
Because it was a building that was sitting vacant in the shop, and they didn't want to see from it one day.
Because you're lying.
So it was Paul's grocery, and Paul was this really nice old man. So we like always went in there and buy stuff, and they didn't want to see it. So there's a partnership of it, so they can make money off of it. All right, that is all the time that we have for today. We will pick up conditional probabilities tomorrow. My guess with what we're gonna do,
Oh no?
I don't know. I don't even want to predict.
Are you kidding me?
We might just do 82 and 83 and then take like a mini mastery or something. I don't know what I'm doing tomorrow.
On Monday, a lot of us are probably going to be
Wait,
gone.
what's your homework?
Let's see, eat, you,
I'm
and
just
then
I'm going to try to avoid
class.
doing
We're coming back at like 1, I think.
Like today.
So 600.
Yeah. You're fully prepared for today's homework. You should be fine. Ryan, one thing you don't do that we learned in elementary school is touch things that aren't yours. The thing you especially don't do is grab somebody else's Bible.
Yes.